The furthest planet from the Sun, the sentinel at the outer edge of our solar system, is a beautiful blue ball of mysteries. But how much do we really know about the distant world of Neptune? Neptune was actually the first ever planet to be discovered by mathematical prediction. After the discovery of Uranus, astronomers tried to calculate the orbital path of Uranus, and they found that it wasn't quite matching their mathematical predictions. So they thought that behind Uranus must exist another planet that is perturbing its orbit. And then a French astronomer called Aubin Le Verrier mathematically predicted where this new planet should be. And on the 23rd of September 1846, the planet Neptune was discovered by Johann Galle, approximately 2 degrees from where Le Verrier predicted it. A real breakthrough in mathematical astronomy. As I mentioned, it is the furthest planet from the Sun. Neptune is 4.5 billion kilometers from the Sun, which is about 30 times the distance between the Earth and the Sun. And in turn that of course means it takes the longest to orbit the Sun out of all the planets. It takes a whopping 164 years to complete just one circuit around the Sun. And so that means that since its discovery in 1846, Neptune's only completed one orbit of the Sun. Neptune spins once on its axis every 16 hours and 6 minutes, so that's its day. And it seems to be that all of the gas giants have faster days than the inner planets. Whether that's a coincidence or just a feature of gas giants is simply unknown. Neptune has an axial tilt of about 28 degrees, which means it's at a similar-ish tilt to Earth, Mars and Saturn. So all 4 planets experience the same seasonal variations, albeit, of course, different lengths. It has a diameter of around 49,000 kilometers, making it the smallest of all the gas giants, smaller than Uranus. But despite the fact that it's smaller than Uranus, it is actually more massive than Uranus. It's 17 times the mass of the Earth, whereas Uranus is about 14.5 times the mass of the Earth. And so in turn that means Neptune is the planet with the second strongest gravitational pull in the solar system, behind Jupiter, about 14% stronger than Earth's gravity. This also gives it the highest density of all the gas giants in the solar system at 1.64 grams per centimeter cubed. Neptune also has a rather strange temperature. It's actually a higher temperature on average than Uranus, about minus 214 degrees Celsius in the cloud tops. Of course that's bloody freezing, but Uranus is about 10 degrees cooler. The sunlight on Neptune is more than twice as dim as it is on Uranus, so that means its extra heat must be coming from within. It must have an internal heat source. And so that means Neptune is emitting more heat than Uranus, and the fact that Neptune's internal heat source is working and Uranus is not is a great mystery that we just don't know the answer to at the moment. And this might explain why we see so much detail in its atmosphere. Neptune has a very active atmosphere. It's full of swirling storms and massive cloud formations and winds that whip around the planet at supersonic speeds over 2,000 kilometers per hour. Those are the highest wind speeds anywhere in the solar system. That puts hurricanes on Earth to shame. Hurricanes on Earth are a mere breeze on Neptune. Now, we've only visited Neptune once in all of human history, and that was in August 1989 with Voyager 2. Voyager 2, when it arrived at Neptune, of course saw all these incredible cloud formations, but it also saw an enormous planet-sized storm, which was called the Great Dark Spot. People thought at first that when they saw it, it's a bit like Jupiter's Great Red Spot. It's like a permanent storm feature. Except, around about 5 or so years later, the Hubble Space Telescope took a look at Neptune and found that the Great Dark Spot had completely disappeared from the face of the planet. So it seems like Neptune's atmosphere is so dynamic that it creates these temporary, enormous storm systems. The composition of its atmosphere is about 80% hydrogen, 19% helium, and a little bit of methane, and trace amounts of other gases. And it's this methane in the atmosphere that gives Neptune its blue colour. It's a bit like Uranus. Uranus has a significant amount of methane in its atmosphere, and that's because methane reflects blue light. It absorbs red and reflects blue and green. And so that's why we see Uranus and Neptune looking blue. It's because of the methane in its atmosphere. Now, a bit like Uranus, the interior of Neptune is not very well studied, but it appears to be a sort of mix of possibly ices down below instead of the sort of metallic liquids. Now, Neptune, just like Uranus, has a very strange magnetic field alignment with its axial poles. The magnetic poles of the planet are about 47 degrees off of the axial poles. With Uranus, it's 59 degrees off. So these are huge angles at which the magnetic field is being distorted at. And so in the Uranus video I suggested whether this is a feature unique to ice giants, we don't know. I did a bit of research on the internet since the Uranus video came out, and we do now know actually that it is very likely a feature unique to ice giants. Let me explain why. Now, to have a magnetic field, an object must have an interior of electrically conducting liquid flowing around in its interior, and that generates a magnetic field by dynamo theory. We thought that the case with Neptune and Uranus was going to be the same with Jupiter and Saturn with its magnetic field. It must have like metallic hydrogen or something deep in its interior. That was until we found out that Neptune's magnetic field was off. It may be still being generated in a metallic hydrogen layer, but the fact that these poles are so off makes us think there's something else going on. Recently, a team pointed one of the world's most powerful lasers at a droplet of ice, and it put it under such immense pressure that it turned into something we call super-ionic ice. It's a very complex form of ice. In ice you have these hydrogen and oxygen bonds, they're bonded together strongly, but in super-ionic ice, the oxygens are still bonded together strongly, but the hydrogens are free to move through the crystal lattice. That means that super-ionic ice is an electrical conductor, whereas ice on its own is not an electrical conductor. And so that results in aurorae appearing at the equators on the planets. It's very strange, but what can I say? The universe has far better imagination than us. Now you can clearly see me flying around on Space Engine. Neptune has a couple of rings, and they're very, very faint. They're only detectable properly by infrared imaging. Like the James Webb Space Telescope could see them pretty easily. The only way Voyager 2 saw them was by completely blocking out the planet and using a very long exposure to try and get the rings in focus. And we saw that the rings almost have like different areas of thickness in the rings. Some parts are thinner, some parts are thicker, and so that's probably some gravitational interactions. I mean, we barely know anything about Neptune's rings, so there's either some other moons there that we haven't discovered or something different. Speaking of the moons, Neptune has 16 currently known moons, and there's only really one of them that jumps out, and that's Triton, by far the biggest moon in the Neptunian system. It's over 2,700 kilometers across. The next biggest one, Proteus, is about 6.5 times smaller than Triton. Triton is a mega interesting world that may hold secrets to the Neptunian system. Like, for example, it may solve the reason why Neptune doesn't have a proper moon system. But we'll go on to Triton in a future video. Now, of course, Neptune has only been visited once by Voyager 2 in 1989, and unfortunately there aren't any future missions planned yet, but there are several concepts being studied by different space agencies to try and get an orbiter out there. It'll be a very expensive mission to go all the way out there and enter orbit, but my god, the science we'll get from there will be stunning. I will go absolutely nuts if a Neptune mission is approved. But for now, I think Neptune's mysteries will remain just that, a mystery. And who knows what we'll discover at this stunning blue ball out at the very edge of our solar system. Thank you everyone for watching this video. I hope you all enjoyed it. That is the finale of the planet series. Next we are going to go on to other solar system objects. The moons are just as interesting, if not even more interesting than the planets in some ways. Thank you everyone for watching, and I'll see you all in the next video. Goodbye!